Okay, let's do some revision on differential equations. Obviously, I'm recording this, so I'll put it up on YouTube and Moodle, something for you to refer back on. Now, the main method for core 4, which we're gonna, which you have to go through, is the method of separation of variables. Okay, that's the main method which we're going to solve. It's the only method you're going to solve in core 4. And the idea is, if we have an equation where dy dx is equal to something, and that something we can separate it into a function of x multiplied by a function of y, then we can use this method of separation of variables to solve this equation. And the key is, how can we separate the function into whatever dy dx is equal to into the function of x and the function of y multiplied together. Now this is the hard spot sometimes. Sometimes it can be quite easy to spot how you can separate them. Sometimes it's quite difficult. Okay? So let's have a look at an easy example. This will be an example of something which could potentially come up in section A, if you like. And let's have a look at dy dx is equal to x squared multiplied by y. This is quite obvious in terms of what the two functions are which are multiplied together. What's the function of x? So we've got this function of x, which is going to be the x squared, lovely jubbly. And what's the function of y then? Just y. Okay. So we've found the fact that there's two functions multiplied together, which one of them is a function of x, one of them is a function of y. Now, once we've discovered that, it should be relatively straightforward. What do we do next? Now we've found out what these two things are. What do we do? Can anybody remember? Adam. Yeah, we put all of the y's on the same side as the dy dx's, and we put the function of x where it is. So to get it onto the other side, I need to divide by y. So we get 1 over y is equal to dy dx. 1 over y dy dx is equal to x squared. Okay, so we put all of the y's on the side with dy dx. Okay. Now what do we do?
Integrate both sides.
We integrate both sides with respect to x. Now what happens then, and we don't have to write this down each time, but if we integrate with respect to dx, to x, the dx is cancelled, so the left-hand side becomes the integral of 1 over y dy, and the right-hand side is the integral of x squared dx. And from now on in, really, it's using your core 3 methods of integration to be able to solve this problem. And that's why we had to do integration in core 4 again, because you have to remember all these methods. The integral of 1 over y, what is that? That should be a standard result. Matty? Ln y. Okay? Now, the integral of x squared, Tom.
X cubed over 3.
Yeah, x cubed over 3. But we need a constant of integration. And constants of integration are really important in differential equations. I don't need one on both sides. I'll just put it on this side there. So I'll put that as plus c. Now we still haven't we've solved the equation, but we need to get it in terms of y. Here I've got ln y. How do we get rid of that ln? What do we have to do to both sides, Becky? Take exponential e's to both sides. So y is equal to e to the power of x cubed over 3 plus c. And in this case, I don't like having that c in the power. Can you remember how we deal with that e to the power of c? Go on, Ellen. Yeah. Basically, and I'll do some different colour because you don't have to write this down each time. But basically, this becomes e to the x cubed over 3 multiplied by e to the c. Remembering that we've got those power rules where two things multiplied together, the powers add up, if that thing is the same. Now, c is a random number, it's an arbitrary constant. Could be anything. E to the c is just going to be an arbitrary constant, it's just going to be any random number. So therefore, it's often best to write our answer as y is equal to a e to the x cubed over 3. That's a neater way of writing our answer. How would we find a? We haven't got enough information in this question to start with, but how would we find a? Georgie? Exactly. If we had some coordinates, so if I say that 0, 3 is in the solution, then we can solve it to find a, because what sub them is, so we get y is 3 is equal to a e to the 0 cubed over 3. So what's e to the 0? Mez? 1. He doesn't want to have a voice on YouTube. So we get 3 is equal to a, and so our particular solution is y is equal to 3 e to the x cubed over 3, and we're done. Sometimes they might ask for a general solution, in which case it's fine to leave your answer like that. If they ask for a particular solution, then you need to find out your value of your arbitrary constant. Okay? Now, let's do something a little bit next level. Okay? Let's go on to a typical section B question. Now, what makes it a section B question is usually often they introduce some kind of real life into what the y's and the x's mean. They might not even use y's and x's. They might use p's and t's, all of this stuff. Okay. They'll also make it more difficult by introducing proportionality. Okay. So I'm not going to set this out like I would do a proper exam question. I'm just going to kind of make up a kind of typical example. And they might say, let Q be, right, let's think of a random quantity, real life quantity. Let Q be the amount of, I don't know, what are those Jaffa cakes? There we go. Amount of Jaffa cakes consumed at a given time t. Okay, so completely random. Don't worry about what the Q and the T actually represent. We're just worried about the maths. They might then say Q is proportional to Q plus 2 multiplied by Q minus 1. oh sorry, no, dq dt is proportional to q plus 2 multiplied by q minus 1. You might have to figure out this, actually. This one's quite a tricky one, so I've chosen it like this. They would probably give you this. But it might be that the rate of change of q is proportional to q. But you might have to figure this out. And they'll say, initially, q is equal to 3 and dq dt is equal to 6. Okay. And the first question they might ask is find a differential equation for q. So this is just forming the differential equation. We've got to really remember how we use proportionality here. So how can we change this proportionality statement into a differential equation? How?
Don't you have to set it to whatever is equal to times the constant?
Yes. Yeah. So it's equal to, we often use k, q plus 2 q minus 1. Good. And we need to find k. How do we find k with the information I've given Steph? Yeah, you summon these values here. dq initially, so that's t, when t is 0, there's no t in here, so it doesn't matter. dq dt is 6. K lots, so we get 3 plus 2, which is 5, multiplied by 3 minus 2, which is 3 minus 1, which is minus 2. You agree? 3, yeah, I don't know where I got that from. 2. So k is equal to 6 tenths, which is 3 fifths. So our differential equation becomes dq dt is equal to 3 fifths q plus 3 q minus 2. Yes, Carl?
What do you mean plus 2 and minus 1?
Yeah, was it minus 1?
Yeah, plus 2.
Plus 2 and minus 1, sorry, yeah. What do you reckon they might ask in the next bit? Set up the equation, what might they ask now, Adam?
Find like the q equation. So y equals.
Yeah, solve it. Yeah, now, to be honest, with something like this, they're probably going to ask you a question before that. As we'll see later what that question will be. But here we need, right, now forget about the y and the x's. Here we've got q's and t's. So we need to separate this out into a function of q and a function of t. Now, it's obvious that this is a good function of q. And we're going to leave this, I could say that 3 fifths is a function of q as well. I could say that. But I'm going to make it a function, I'm going to pretend it's a function of t. I'm going to separate it like that. And I'm going to divide everything, get all the q's on the other side. Okay? And so we end up with 1 over q plus 2, q minus 1 is equal to 3 fifths. Ah, no it isn't. There's dq dt there as well. Okay, now, what do we do now, Alan? Integrate, yes. So we get the integral of 1 over q plus 2 q minus 1 dq is equal to the integral of 3/5 dt. Now, if we integrate this is a piece of cake. 3/5 integrated becomes 3/5 t. This, on the other hand, is where we're going to get our marks from. Now, I'd say as a rule of thumb, make your substitution rule whatever the denominator is. Trouble is here we've got two different denominators. So here is we need a special method which they'd have probably asked you to do in the previous part of the question. Tom, what do you think we need to do with this fraction? Integration by parts.
Oh, sorry, I'm an idiot.
Partial fractions. Yes, when we get something like this is a core 4 method, we need to write this as partial fractions. This is where it gets a bit mega. And actually, probably in the question they'd have asked you to do this by partial fractions in part 1. So after, it's almost like a blue Peter, after one which I made earlier, after doing the partial fractions earlier, here's one that I made earlier, yeah, get it right. We end up with the integral of minus 1 over 3 lots of q plus 2 dq plus 1 over 3 lots of q minus 1 dq is equal to, well, that's 3/5 t plus constant. I've integrated that straight away because that's quite straightforward. Now, what am I going to do with this minus a third for this integration, Carl? Yeah. This 1/3 I'll take outside as well. Some of you might be able to do this in quicker steps, but okay. Now, to solve these, you'd do it by substitution. Make u is equal to q plus 2. Now, can anybody just spot what the solution is going to be then? Steph? Yeah, why is this just... Yeah, it's just going to... This one, because it's 1 over q plus 2, if we integrate this, we end up with ln of q plus 2. To do this, you'd use substitution. Now, some of you can spot that that's going to equal that. Some of you do it by substitution. That's not a problem. Let u equal q plus 2. Things work out nicely. And actually, we know with this one as well that this becomes ln q minus 1. And that's going to be equal to 3/5 t plus c. Now, you may have noticed here I haven't got brackets. I've got the mod symbols. Okay, and this is something which I've kind of held back from you up to now. But whenever we do some integration and we end up with a ln function, we have to have the mod symbol. What does the mod symbol do? Can you remember, Carl? Yeah, so if q plus 2 is negative, it just makes it positive. Why is it then quite important that we have it for this ln function? Carl, again. Yeah, we can't have a ln of a negative number. Now, in practice, I'm not going to go over the proof about why we can do that. If ln of the negative number, we can just take away a negative. Take away the negative, because in general we can't. But when it's to do with integration, we have it as we can. And I'm not going to go over the proof of that, but you can have a look at that as you wish. Now, if again writing this, because we still have got to work out this solution, it's ln of q minus 1 minus a third ln of q minus 1 minus a third ln of q plus 2 is equal to 3/5 t plus c. Again, Carl's Obviously trying to show off on the video. Yeah, joke's on you. It is. So rules of logs, we subtract them, so that means that we can divide them. So it's a third of ln q minus 1 all over q plus 2 is equal to 3/5 t plus c. And then we need to rearrange it for q, which is a bit of an algebra trawl. Multiply by 3. And we get 9/5 t. Now, multiplying an arbitrary constant by 3, we're still going to get an arbitrary constant. Now, I think to be safe, I'm going to call that a different arbitrary constant called d. Okay, just to be safe. Make sure that I don't lose any marks, because even though we're timesing the random number by 3, it's still a random number. We'll call it a different letter. Now we can take exponentials. And we get an arbitrary constant a multiplied by e to the 9/5 t. But we still haven't rearranged it for q. This is worst case scenario, this. Yeah, we're going to have to multiply by q plus 2. So we get a e to the 9/5 t multiplied by q plus 2. Multiplying out these brackets, we get q minus 1 is equal to a q e to the 9/5 t plus 2a e to the 9/5 t. Putting all of the q's on one side, we get q minus a q e to the 9/5 t is equal to, putting that plus 1 on the other side, or minus 1 on the other side, 2ae to the 9/5 t. Finally, factorising q, 1 minus ae to the 9/5 t. And finally dividing by what's the multiplier of q, and we get that is our final result, and we've done that, and then we have a little sleep, because that's quite a lot of work. The worst case scenario for the exam. I know I went through that quite quickly, but the beauty is I've recorded it. You can go on YouTube, like it, write a nice little comment if you like. Saying how good the solution was. Okay. Any questions?